Professor C, can I ask you a quick question before we start?
Give me just a moment because I'm still distracted while I'm trying to get set up here.
Okay.
So if you have just hold on to it for just a moment. I guess we don't have time to do that, so I'm not gonna worry about that. Share my screen. Start the broadcast. Okay. Let me see. So there is at least one person that I let in just now. It just says Zoom user. So you just need to send me a DM. One, whenever you get a chance, you need to update your screen name so it says your student name, so that because I take attendance to let you all in. So there's only one person in here that didn't get their attendance credit today or that hasn't gotten it yet. So just DM me. Just DM me.
I changed it.
Yeah. What's your name? What's your last name?
It's Davis
What's your first name?
Layton.
Okay, I got you. Yeah. Let me do announcements. I know there were a few questions. Just let me do announcements, and hopefully my announcements can answer some questions. And then if not, we can go from there. Let me start here. Let me see. So hope everyone had a good weekend. What is this, week 3? So like if you or any of your classmates like were booted and you intend to stay, just one, let me know before like towards the end of class today. And then two, send me an email saying that you'd like to stay in the course, and I'll just forward it to the records and be like, hey, can you be sure to reinstate the student? I guess with those like no shows, they kind of booted people. It was kind of like a unofficial purge, but basically anybody that asked to be put back in the class was put back in the class. All right. So as long as you really want to be there, you were put back in and you were good to go. So I'm not sure if that I know that was a major issue over the past couple of days. Other things would be like, it's mainly just gaining full access to my math lab and submitting your assignments. Remember, if you submit any assignment late, there's a 5% late penalty. So the highest you can earn is a 95%, which I think is still good. Like if you submit something late, you can still earn up to a 95%, which I think is the bomb diggity, right? Couldn't think of any word in that moment. And we still get unlimited attempts. And again, the system is set to take a high score. Okay, let me kind of open the floor for a few questions. I know that you guys had some concerns. And then one other thing is like, if you guys email me and I don't respond, the best thing is to use my office cell phone number. Either send me a text or call me. That's because then I'll know it's you all. When I get so many emails that I just ignore them because I just get to me, right? So that's why I created my whole office cell phone thing. Okay, let me open the floor. I know there were a couple of questions. I don't know if they got answered or not. Going once. Maybe
So
they got
we so if I didn't complete an assignment before the due date today at 6 o'clock, I can still keep working on it, right?
Of course, yeah. Yep.
All right.
All of our assignments, including exams, we get unlimited attempts. The system is set to take a higher score, and there's only a 5% late penalty. So if you submit it late, you get a perfect score. The highest you can earn is a 95%, which I think is still really good. All right. Any other questions, comments, or concerns before
It says not. It says 10% on here. So it is in your system. Is it 5?
No, I need to change it. I don't think I changed it. If you remind me towards the end of class, just somebody remind me towards the end of class, and I'll try to go through those and change all those.
Okay, so it'll update for it. Okay, thank you.
Yeah. If you remind me, I'll try to update it. I'm in 35. Yeah.
All right, thank you.
Okay, so let me check Zoom one more time. So again, I usually do my waves. Let me check. I got a couple. So let me get these gentlemen. Some of these names look familiar.
Hey, Mr. Frank.
Yes.
I was just making sure I was on your roster because I did get a no-show, but I believe you put me back into class, but I'm just trying to make sure.
What's your last name?
Jones.
What's your first name?
Dylan.
Yeah, I think you're here because if I don't say anything, like when you get into the Zoom, that means that you're on my roster. So yeah, I have you. So I think you're okay. I have you on my roster now. I see you. I would just check on your end, like maybe check Bannerweb and just make sure and confirm. But on my end, I see you. You got your tennis credit for the day. Okay. Yeah. All right. So let me see. All right, so the goal for this week are the next 4 sections, right? So wait a minute, is that right? Yeah. So the goal for this week is sections 1, 5, 1, 6, 1, 7, and 1, 8. So what that means is that idealistically today we can get through 1, 5, and 1, 6. So that's about 30 minutes a section, which is definitely not enough time. But again, whatever we don't do together, I do expect you all to use my pre-recorded lectures. Because again, I took my time to go through all the examples or all the necessary details. So again, whatever we don't do together, I expect you to use that. Let's take some time and get into this. So we're going to start with section 1.5, Leibniz notation and the power and sum difference rules, right? So I think last time we explored the limit definition of derivative. And it, sometimes doing those difference quotients, the algebra with that, it can be a little bit like, lengthy and, like if you're not writing big and spacious and organized, it's easy to miss something and kind of get stuck. I think this is getting into like some of those shortcuts, right? Where you don't really have to do the limit definition, the limit definition of the difference quotient. You don't really have to do that. We have ways that are much more efficient to do those calculations, right? Again, that kind of served as like an introduction. So a few objectives here. One, differentiate using the power rule or the sum difference rule. Siri, set a timer for 30 minutes.
30 minutes starting now.
Differentiate a constant or a constant times a function. Determine points at which a tangent line has a specified slope. Another thing I want to kind of bring to your attention is that the derivative is just the slope of a tangent line at a point, right? That's essentially what the derivative is. So when y is a function of x, we will also designate the derivative f prime as dy by dx, which is read the derivative of y with respect to x, right? So last time, we introduced the limit definition of derivative. It was the limit as h tends to 0 of the difference quotient, right? And so that was our f prime. And so then here, we're just using an alternate notation for derivative, which is this dy by dx. I think that's Leibniz notation, okay? And it's read the derivative of y with respect to x, okay? So for any real number k, the derivative of y with respect to x of a power function, right? So it's the power rule, is going to be basically you bring down the power and then subtract 1 from the power, right? So like for instance, if we try to find the derivative of this like we did last class, I think we did this one actually. It was like find f prime of x squared and using the difference quotient. Then we had to like FOIL, combine like terms, factor, divide, all this kind of jazz. All that gets condensed down to just like one step, right? So basically what this is saying is that whenever we take the derivative of a power function, that's going to be equal to the power times 1 minus the, x to the power of, you basically subtract 1 from the power. Okay, let's just see it in action, right? I feel like that'll be much cleaner or smoother if we see it in action. 7 minutes until 15. So hopefully, again, if you have brothers in the waiting room, just tell them if you ever miss that first wave, just stay in the waiting room and I'll let you in and I'll log it. Again, I usually do it in 2 main waves, and I might check it again after the 15-minute mark, like a 3rd or 4th wave. But so if you miss that second wave, just stay in the waiting room, and you more than likely you get your credit. Okay. So for instance, for part A here, right? So if we wanted to find the derivative of y with respect to x, the power rule, all it's saying is that the power comes down, so 5 comes down, and we subtract 1 from the power. So 5 minus 1 is a 4. That's the derivative, right? So again, last class, all of that would have taken up this whole screen. All of that work has been condensed down into just one step. That's the power rule, right? Let's take a look at B. So the derivative of y with respect to x, the power comes down, which is a 1, and if we subtract 1 from the power, it's going to be x to the power of 0. X to the power of 0 is 1. So the derivative of x is just 1. Okay? And then C, so the derivative of y with respect to x is going to be the power comes down, and then we subtract 1 from the power. So it's going to be -4 minus 1. Okay? So that's going to be a -4x to the power of -5. Okay. So this is, I don't know if you remember, like when I first introduced derivatives, I was like, once we get on the far side of the limit definition of derivative, we have all these shortcuts. So this is the first of several of our shortcuts to find a derivative. Okay, and you could confirm these, right? If you did the limit definition, limit of the difference quotient definition, you should get these same results. The limit is h tends to 0 of the difference quotient, right? I'm trying to talk too fast. Yeah, I don't know.
I have a quick question. Sorry.
Yes, good.
All right. So in terms of letter A, okay. So with letter A, it's 5x to the power of 4, right? So essentially with this, we're kind of flipping it around. So it'd be what? It would be 5x to the power of 5 minus 1 in order to get 4. Because I'm just trying to make that connect.
Yeah, 5 minus 1 to get the 4. Right.
Okay.
I didn't show those details. I did the same thing in A, B, and C. I only showed the details in C.
Okay.
Yeah. So like the way I did C is the way I did A and B.
All right. Thank you.
Okay, let me see. And here's a typed version of what we just did. And they have more of the details, right? But essentially what you see here typed is what we did. Okay. I'm gonna leave this as an exercise. Okay. So I think we can still apply the same technique here, right? With the power rule, right? So for instance, in part A, we have y equals the square root of x, and we want to find dy by dx. So first let's rewrite the radical, rewrite it as a rational exponent, right? So then for part A, y is equal to x to the power of, how do we rewrite square root as a rational power? That's going to be the same as x to the power of
It's a half.
1/2, right? So then if we apply the power rule, right, when we go to find dy by dx, the power comes down and we subtract 1, right? So then our dy by dx, the 1/2 comes down, and then 1/2 minus 1 is going to give us a negative 1/2, right? And so it's really root x over 2x or whatever, but I'm just going to leave it like this for now. Okay, so let me see. Same thing for B. We want to find the derivative of y with respect to x. The power comes down. And then if we subtract 1 from the power, what is that, a negative 0.3? I'm just going to leave it like that for now. So the notes did at least take the first one a little bit further. So we'll go ahead and go a little further as well. So a negative power moves it to the denominator, x, so it's 1 over x to the 1/2, which is the same as 2 times the square root of x, under 1 like that. And usually we don't leave radicals in the denominator, we usually rationalize. Yeah, but they left it there, so yeah. Say you were on an exam, if you submit this and they take off because it's supposed to be this, bring it to my attention. I'll probably give you credit for it. Or if you rationalize this denominator, they should give you credit for it, even if you rationalize. But I'll give you credit provided the instructions, you got to be sure to follow the instructions, right? If they say make sure that the final result is in like positive exponents or whatever, a lot of times they don't accept the negative powers. But again, if you submit something on like an exam, if you want to challenge it, just bring it to my attention and we can kind of go back and forth and you can probably recover some partial credit. It just depends on the question and what you put. Okay. So not too bad on those. So these couple of examples were showcasing the power rule for finding a derivative. Okay. So now we want to look at the derivative of a constant. All right. The derivative of a constant is 0. All right. Yeah, I mean, that's another way you can consider it. A constant is the same as that constant times x to the power of 0. And then when you apply the power rule, let me think. Let me see if that works. Give me a moment. It should work. I don't see why it doesn't, but give me a moment. Like for instance, if we had, so 2 times x to the power of 0. Why isn't that working? Because that comes down, you get zero. Oh, it is working. See, I was getting stuck because I was like, well, every time I do this, it's collapsing to zero. I was like, what? But it's supposed to collapse to zero, right? So say this was our y, and we found dy by dx, right? The power comes down, so we're going to have 2 times 0 times x to the power of minus 1. That 0 forces this whole thing to go to 0. All right, you're essentially going to have 0 over x, so it forces it to 0. All right, so because of this, the derivative of a constant is 0. Okay, let me check Zoom. All right, so I think we do have a few in the waiting room. Let me get these gentlemen. I think it might be everybody. Okay, I think this is the student. I'll try to make another announcement. Ooh. Okay, you guys are looking good. Okay, I think we got everybody. Let's see what's going on here. Mr. Neal. Let me see. I think I remember I saw your name. Mr. Neal, I would encourage you. Let me check. Let me go here. Mark these gentlemen is absent. How could I see it? Maybe if I go like this. Is judging. Yeah. So, Mr. Neal, I do have you on my roster. You could have been dropped and put back. I know that happened to a lot of students. So, but I see you right now. I would encourage you to just check on Bannerweb to make sure that my course is added, that you can still see my course, and just go from there. And then also, if you don't see it, if you're trying to reach me, best is to use my office cell phone. And I know we had some people that just joined. Be sure that your username shows your official student name, like your first name and last name. I know I had another student just now. I think I got the right student. Yes. Okay. Just be sure that your first and last name is shown. But I think I got everybody. There was one who didn't have the last name, but I think I found them. Okay. But that's just important just for ease, just to make things simple.
Hello.
Yes.
Hello. So I've been having a problem with my internet. It's like the full internet has been messing up, and so I wasn't able to complete the chapter 2 homework assignments and the quiz.
It's okay. Honestly, all of our assignments have an automatic extension built into them. You can submit assignments late. You still get unlimited attempts. There is the 5% late penalty does stand, but I mean, there's not a big difference between 9. Oh, now I do need to update the settings. I think they still might say 10%, but I do intend to change them to 5%. Right. So I'd rather just do 5%. I think that's a little bit more reasonable. So, you can still earn up to 95%, which I think is pretty good. I have had students that waited to the last 2 weeks of class and submitted all their assignments in those last 2 weeks, and they pretty much maxed out a lot of scores. And at that time, I was doing 10% late penalty, and they walked away with a high B, maybe an A. I think one student was actually able to get an A doing that, but yeah, I do intend to change. I just need somebody to remind me towards the end of class. But I'll change the late penalty from a 10% to a 5%.
All right, thank you.
Okay, let's see. So, all right. So the derivative of a constant is 0, right? Let me see. The derivative of a constant times a function is going to be the constant times the derivative, right? So we just went through 2 more of the shortcuts for finding the derivative, right? Again, the derivative of a constant is 0. The derivative of a constant times the function is going to be the constant times the derivative, right? Okay. So here we're asked to find each of the following derivative. So the derivative with respect to x of this function, right? Let me see. The 4 comes down. So for A, it's going to be basically 7 times 4 to give us 28 times X, and then 4 minus 1 gives us the 3. Okay. Why do I keep writing my 3s like that? Yeah, it's a little bit better. All right, let's not have to be. All right. So the derivative with respect to X of that function, we got this. Okay, so then for B, so the constant just kind of persists. The derivative of X is just 1, so I think that's our final result. It's just -9. Because, you know, X has a power of 1, the 1 comes down, and then when you say 1 minus 1, it becomes X to the power of 0, which is just 1. So then ultimately that one is just -9. I think for D, I'm going to rewrite it first.
I got a question.
And for C, yes.
So I'm not understanding A. Like, how did you get 28?
If I had X to the power of 4, how would you find that derivative?
Would I like do 7?
If I had X to the power of 4, what
put
do
4 on
we do with the 4?
the 4 on the other
Yeah.
side? Oh, okay.
It comes,
I get it now.
Yeah.
I get it now.
yeah, it comes down in front, right? And then the power becomes what?
Power become, you do 7 times 4, and then you put
Okay.
that X3. Yeah, I get it
Yeah.
now.
Yeah. So it's the same as what we just did a moment ago. It's just the 7 kind of lingers out in front, right? So like how we did for example 2. Trying to get back to example 1. Right? Same thing we did in example 1 where the 5 comes down and we subtracted 1. It's the exact same thing. It's just there's a 7 lingering out in front for that example. Right?
Oh,
But
okay.
it's the
Thank
same.
you.
Yeah, it's the same thing. Okay. Like, yeah, don't overthink it. Not right now. Because that's just gonna make it harder for like no reason. Let me try this one. Okay. So for C, I'm gonna rewrite it, right? I'm gonna leave the 1/5, right? But instead of writing it as 1/x², I'm gonna rewrite it as x to the power of -2. Okay. And then I'm gonna find a derivative, right? So that 1/5 just persists. Nope, sorry. That 1/5 just persists in front. And then now we apply the power rule, right? The -2 comes down and we subtract 1, right? So then it's going to be a -2 times x to the power of -3. So then -2 by 5. I think that's it. -2 by 5 x to the -3. We really shouldn't leave a negative power. Sometimes they accept it, sometimes they don't. They might put -2 over 5x to the power of 3. So I personally would accept either of those. It just depends on what the instructions say. Because sometimes they're explicit, like don't leave a negative power. They'll say that explicitly. I think we got A, 28x to the power of 3. Okay. B, we got -9. Yep. And then C, we got this -2 over 5x cubed. Okay, and they accepted both, right? They said, yeah, the -2 over 5x cubed or the way we had it before, right? Sometimes they accept the negative power and sometimes they want it in this. They're pretty good about being clear with their instructions. In all honesty, my math lab a lot of times is like too precise, and like sometimes students struggle with that too. Like it says, round to 2 decimal places or write your answer as a whatever the instructions are. Just you got to do your best to like follow the instructions. But again, whatever result you get, you can always challenge it. Just bring it to my attention and we can talk about it. Okay. So we saw some examples with the power rule and like a constant times a function. The constant really just kind of lingers in front of the derivative. Okay, let's see another one. Okay, so we have the sum difference rule, right? So the derivative of a sum is the same as the sum of the derivatives. The derivative of a difference is the same as the difference of the derivatives. It's almost like we're distributing the derivative into it, but it's not really distribution. But you can kind of treat it like that in this instance. All right. So let's just try to see. I feel like these sink in better if we just see it in action. So for instance, in part A, we have the derivative with respect to x of this binomial, right? So this is really just going to be the derivative of the first thing minus the derivative of the second thing. Okay. So if we just focus on the first term, can anybody walk me through finding the derivative of that first term? What are we going to do? All right. What do we do with the 3? All right.
You make it to a 2.
So
Oh no, you move it over.
it will come a 2, right? That is coming. But what do we do first before we make it a 2?
You move the 3 over to about a 5.
And then so the 3 comes down. It's going to be 5 times 3 to give us
15.
Yep. And then we say minus 1 to give us the 2. What's the derivative of a constant? So it's something we said earlier today. Suppose I had can somebody tell me what's the derivative of x cubed? What's the derivative of this guy?
1 divided by 3.
Not divide, but
Oh, sorry.
if we do the same thing, right?
Oh,
so
it's just 3
what? 3x
cubed, right?
If we subtract 1,
Oh, it's 2. 7 squared.
okay, let's try another one. Somebody tell me the derivative. What if we had x to the power of 7? What's that derivative going to be? What do we do first?
7x to the power of 6.
7x. Okay, let me do 2 more. Let's go this one. What's d by dx of, what time is it? Let's do 9. If we had x to the power of 9, what's that result going to be?
It'll be 9x minus 8. No. Yeah, 9 minus 1, and then it'll be 8.
Yeah, to the power of 8. Okay, so now, what if we had d by dx of x to the power of 0? If we do the same thing, tell me about that one.
It'll just be x.
What do we do with the 0?
You move it to the front, but
Okay, 0 times x to the power of, what's 0 minus 1?
0.
What's 0 minus 1?
-1.
Okay, so then so basically that means we have 0 over x. That's really just 0, right? And all of these, all we're doing for the power function, just bring the power down to the front and then subtract 1 from the exponent, right? We did the exact same thing just for different numbers. Power comes down, minus 1. There's the power, 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 minus 1. It just simplifies down to 0, right? So the reason I did that, I was trying to get you guys to see the pattern with the, because that's supposed to be like a freebie. So then, what do you think happens with this guy, right? Let me see. I need another color. I guess I can do this color, but this will be fine, right? So now, let me work on number 7 up here. I mean, part that -7. So constant, right? If we find the d by dx of a constant, which is in this case is -7, that's the same as 7 times x to the power 0. So now we just did a moment ago where we had, what's the derivative of x to the power 0 again? All right. So if a constant can be written this way, the derivative of a constant is just going to be 0. And these will become second nature, right? I feel like there's a little bit of lag because we just introduced it, right? So that becomes just this, right? But honestly, after you do it, like you'll see it's the same thing over and over, just with different numbers, right? And so you don't even think about it. It gets to the point where you're not even thinking about it anymore. But again, I'm just chalking it to like, we just introduced it, right? We still might be considering, limit definition at the difference quotient. But after you've like gone through it a little bit, you'll see it's kind of like the same thing over and over with just different numbers. It really does become second nature. So like all of those colors, those are all the same things, just with different numbers. Okay, so let's try B. I kind of want you all to do it, but we're almost out of time. We kind of do need to go to the next one. I'm just gonna kind of go a little bit faster here. So the derivative of 24x is just gonna be 24. Let me see, square root of x. So the power comes down, and then it's gonna be x to the negative 1/2. I'm gonna just leave it like that for right now. The last term is what? 5x to the minus 1. So then it's going to become negative 5x to the minus 2. In each of those cases, I did the same thing where the power comes down and then I subtract 1 from the power. Right? It's just that we get these different results. So for instance, for the second term, that's what? Negative x to the 1/2. So then when the 1/2 comes down, that's where this came from. And when I say 1/2 minus 1, that's where this came from, right? In that third term, that's the same as plus 5x to the minus 1. Then I did the same thing again. The minus 1 comes down. That's where the minus 5 comes from. And then minus 1 minus 1, that's where the minus 2 came from, right? So in either of these three cases, I did the same thing. Now, what would help is if maybe we rewrite it first into this form, and then, and even that first one we could have written as, let me use this color. Let me see, 24x to the power of 1. The 1 comes down and you subtract 1, and you get this result. Let me try to wrap this one up. 24, that's going to be 2 times the square root. Square root of x, like this. That's a minus there. And then minus 5 over x squared. Let me see. They might rationalize. They might have us rewrite it as square root of x over 2x. Let me see. Let me just kind of look. That was B. Okay, so what we have is fine. All right. So, and then the other thing about all this, personally, I feel like it is a challenge to like follow somebody else's work, right? Really for these, like for the lives. I mean, I feel like it's a good opportunity to ask questions, but to me, I feel like it's a little bit better if you just kind of let it be conversational. Like, don't try to read too deep into it. Just try to get the main gist. And you really don't see it until you start working it yourself. But if you try to follow my work, you're going to get, like, it's going to bore a hole in your head, because I can't even follow somebody else's work. The only way I can follow somebody else's work, I have to do it myself first. And then, or if I haven't done it myself, I just try to pick up on, like, the main gist or the main pattern. And then, but again, I don't really see it until I go to do it myself. So the main pattern with these few examples is really just been the power rule. The power comes down, and we subtract 1 from the power, and then we do algebra to simplify. But again, I really feel like you really don't see it until you do it. But if you try to follow me, it will kind of like, it's hard to follow. But when you start doing it, you'll see it. Like, that's why I really wanted you guys to do it, so I can get you guys to see it, but we're kind of short on time. Let me pause for the cause. I feel like there are questions. I did the best to try to anticipate them and answer the questions as best I can before you guys ask it. You know, and as always, if anything isn't clear, just stop me. You know, just stop me, because otherwise I'll just power through, and it just kind of spirals from there. Find the points on the graph of this at which the tangent line is horizontal. So if the derivative is the slope of the tangent line, that means this. Okay, if we have a flat horizontal line, what's the slope of a flat horizontal line? So the slope should be, or in other words, our derivative should be 0. So basically what they're asking us to do is to find a derivative and find the values of x that make the derivative 0. Okay. If it's a horizontal line, that means the slope is 0. Derivative is the slope of the tangent line. So they're asking us to find when the slope of the tangent line is equal to 0, what values of x occur when the slope of the tangent line equals 0, right? Long story short, find the derivative and set it to 0. That's all they're asking. So it was kind of like a little bit of misdirection here, right? So if the given function is this guy, let's go ahead and find f prime. The power comes down, subtract 1 becomes this. Power comes down. Siri, stop. 6 times 2 is 12. And then you subtract.
6 times 212 is 1,272.
Thank you, Siri. She's listening too hard. Right? So, right, we just applied the power rule. The 3 came down and we subtracted 1. We got this result. The 2 comes down, so it becomes 6 times 2 and subtracted 1. We got this result. Okay. So then if this is our derivative, we want to set this guy equal to 0 and solve. So it looks like we have a GCF, a greatest common factor. It looks like we could factor out. Can anybody tell me what the greatest common factor here? What
You can factor out 3 or -3 to be exact.
what do these two terms have? Going twice, forever, hold your PX, right? Yeah, that's okay. The 3 probably will be okay. I just didn't want the negative in that leading term, so I made it -3. So if we did -3x, what's left over is an x minus 4, right? And a quick check, right? If we multiply back, -3x times x gives us that guy. -3 times -4 gives us a positive 12x. All right, so we can be confident in this. So then we can apply what's called the zero factor property. When 2 or more things multiply to give us 0, we set each factor to 0 and solve, right? Factors are things that we multiply and divide. Terms are things that we add and subtract, okay? So then from here, what we're saying is -3x equals 0 or x minus 4 equals 0. So then from the first one, we get x equals 0 or x equals 4. Okay. Find the points on the graph at which the tangent line is horizontal. So these values of x make the denominator 0. So then if these are the values of x, we need to find the corresponding y. So for instance, when x is 0, our corresponding f of 0 just ends up being 0, right? When x is 4, I'm going to use my calculator. Let me see. Let me just use a calculator. Clear? Okay, you're not. Okay, there you go. Now let's go to y equals. Now we got this -x to the power of 3 plus 6x squared. Okay. I want to evaluate this when x is 4, 32, right? So we're saying that what? F of 4 equals 32, right? So then what we're saying is that at the origin and at the point 4, 32, we're going to have the slope of the tangent line should be 0. So in a graphical sense, that should be either the bottom of a valley or the peak of a mountain. All right. That should be where it's occurring. So let me see, 4 and 32. Let me change my window to get an appropriate window. I think our X values are good. But then Y, we can go down to -10, but we need to go up to like maybe 40. Yeah, let's go up to 40. And let me see, if we went in steps of 4, that would be 10. Okay, we'll go in steps of 4. Okay. So now notice that there's the bottom of a valley at the origin and a peak. Let me plot this point. So if I go to stat plot, I'm gonna just turn it on, I guess. Stat, edit. So I'm gonna plot the origin. I mean, that was not too hard to see. But then I want to also plot 432. Okay. And I think we turn stat plot on. So we see it passes through the origin and the other peak passes through that other point that we found. Right. Okay. So I just wanted to show you some of the capabilities of there's a TI-83 plus, right? So these are the order pairs that we got. Okay. Let's see the time.
I have a question.
Yes.
So how did you get 0 for the equation for this one?
The blue part 0 or the answer of 0?
The answer is 0.
Okay. So the question asks, find the points on the graph where the tangent line is horizontal. So basically, the tangent line is going to be horizontal, means that the slope is 0. So they were saying, oh, well, the slope of the tangent line is 0. So then basically what they're saying is set the derivative equal to 0 and solve, right? So we were given this guy. I found the derivative. When I found the derivative, I got this result. And then we set it equal to 0, right?
Oh, okay.
Because that's what the question was really asking us to do. We set the derivative equal to 0 and solve. Yeah. And then, okay, if you got it from there, then we factored and then 0 factor property. Right. Okay. Okay. Let me just scan real quick the remaining parts. Let me see. So come on. So we got the origin. Yeah. The origin of 432. And you can see it here, right? So I think we got that same image. Find the points on the graph at which the tangent line has a slope of 6, right? If the tangent line has a slope of 6, that means we set the derivative equal to 6. Let me just do it, right? So it shouldn't take that long. So if our f of x equals a negative x cubed plus 6x squared, our derivative, in this case, the power comes down, subtract 1, power comes down, subtract 1, right? Now we want the derivative, if we want the tangent line to have a slope of 6, that means we set the derivative equal to 6 and we solve. Okay. Let me think. We could divide, so here, if we set it to 0 at this point, negative 3x squared plus 12x minus 6 equals 0. So basically we want to factor this guy. It looks like a GCF, a greatest common factor, looks like it's negative 3. Or we could use the AC method. Let me do the AC method for factoring. So first I'm going to rewrite it. I'm going to factor out a negative 1, divide both sides by negative 1, and I'm going to get a 3x squared minus 12x plus 6 equal to 0, okay? So then if I do the AC method, 6 times 3 gives me, I'm going to work over here, gives me 18. 6 times 3. So then that's 2 times 3 times 3. We're looking for two numbers that multiply to give us 18 and add to give us 12. Okay. So let me see. 1 and 18. All right, but that's no good. Let me see 2. Now, if we use this 2, we have 9 left over. Oh, doesn't work either. 9 and 2 the other side. So maybe we can't factor it this way, like not with the rationals. Let me think about it. We could do the quadratic, and we could also do completing the square. I think I'm gonna showcase completing the square. So if I'm gonna do completing the square, if I divide both sides, I'm gonna divide all terms by 3. I'll show that. So basically, I'm gonna say this divided by 3. I'm basically saying the entire left divided by 3 and the entire right divided by 3, right? And then when we say the entire left, we can distribute that 1/3, and the following happens. That's gone. This becomes a 4. This becomes 2, right? Okay. So then we'll have x squared minus 4x plus 2 equal to 0. Okay, I'm going to keep working over here. So I'm doing completing the square, x squared minus 4x equals -2. So then I'm going to do my b over 2 squared. Quadratic formula might have been a little bit easier. I'm going to say plus -4 over 2 squared. And again, this is called completing the square. -4 over 2 squared. Also, you could have done the quadratic. -b plus or minus the square root of b squared minus 4ac over 2a, right? So you can use that as a reference. Let me try to get this one, wrap this one up. So that's 4 x squared minus 4x plus 4. And that's a 4 minus 2 is a 2. So then the left looks like it factors into x minus 2 squared equals 2. So then x equals 2 plus or minus the square root of 2. Okay. So give me. I'm almost done with this one. Let me wrap this one up, and then we'll go back for questions. The technique that I ended up going with was completing the square. You could have also done the quadratic formula. You should get down to the same point. So these values of x should have the slope of the tangent line at these values of x has a slope of 6, right? That's what this is saying. All right. Let me just check and make sure this is correct, and then we'll entertain questions. So yeah, 2 plus or minus root 2. So again, to find the corresponding, and then I didn't find the corresponding y values. We'd have to plug them into the original function to find the corresponding y. So I'm just gonna kind of piggyback on this. Okay, I know there was a question. I don't know. You can, if you want to try to.
No, I was a little confused at the -4 over 2.
Yeah, this part here.
Yeah, but I was kind of confused only seeing that. I understand why you put it, but I thought it -4 if the -4 at the top was
right. So here, this guy, right? Because I know I kind of
yeah.
a little small, so that kind of makes it harder to see. -4. What's -4 divided by 2? Is what? -2 to 2 is positive. So I was kind of missing some stuff right here, right? This guy was -2. Well, actually, no, I'm not missing anything. We have a -2 plus 4 to give us +2. Okay, let me write it out because I'm not writing everything out. So I'll do it here.
No, I understand the right side. Like I understand that, but the left, it wouldn't, like the -4 over 2, the -2, and then that to 2, that'd be okay, my bad.
Got it. Yeah.
I'm looking at it wrong. I apologize. I understand.
No, you're totally good. And I know it's partly because I was kind of rushing on this one, and I was kind of writing small. But that's what you just experienced is what I was referring to about, like, when you do it yourself, you'll see it, but trying to follow me, it might bore a hole in your head, right? But yeah, I think you see it now, so I think it's okay. And these were just the X values. We do need to kind of go back and find the corresponding Y values. And so what we're saying is that at these points, the slope of the tangent line is going to be a +6, right? Because that's what the question asked for. That was a little bit more involved than I originally thought it was going to be. So that did kind of trip me up a little bit, but I think we're okay. We caught the changes. Okay, so we got those X values. I'm just leaving finding the Y's as an exercise for you just because we're kind of short on time. And here's a pictorial representation, right? I think it's the same function that we had before, but now we're trying to find the values of X where the slope of the tangent line is 6, right? And so here's a pictorial representation of that. Okay, so we actually made it through. Ooh. And we have a solid 25 minutes. Okay. I should have skipped that last one, but I got a little bit cocky or overzealous. Let me go ahead and make a copy of this available. Share. Did y'all change up on me again? Yeah, I want to send it to Box. And they keep updating things. That is not necessarily the right folder. There we go. Spring of 24, traditional, calculus, notes, updated, should be this one. I think I labeled that one incorrectly, but that's okay. Item number 5, so that's loading. Let's take the remaining time that we have in class and try to get through as much of the next section as we can. Let me see. So that was 1.5. So again, with this whole experience, you know, one, I do want you to realize that it is designed and built for most of the learning to be done on your own. Do the best you can with the lives. I know it can be intimidating. Like, I try not to rush, but sometimes I know I rush. And I know if I get flustered, I know it amplifies in you guys. I would just take a deep breath, right? I want you to realize it's gonna be okay. Make a plan and take some action. This is why I encourage you all to collaborate, work together, link up with the tutors, right? Between the tutors, your classmates, my office hours, and the internet, something there has to click, right? Either link up with the tutor, a classmate, either asking me directly, like in office hours, or just, you know, text me or whatever, or, you know, something that you found on the internet. One of those sources should work, right? Beyond that, I don't really know, right? To be honest. Let's take a look at this one. So we're continuing differentiation. And so actually with this one, we're looking at more
There's
of like,
2 of you speaking.
uh-oh. It's like an echo or something. Let me check. I don't know what to do about an echo. Email. Oh, about the late penalty. You guys are funny. Let me see. Let me get this student. Yeah, so that's what Scott.
Also got another question.
Go. Give me just a moment. That's kind of weird. Is there another Scott in here? Maybe he just kind of got knocked off. Go ahead. You have a question?
Yeah, I was trying to, because I just bought the book over the weekend and just got access. I was looking for like the enrollment code or something like that. It's not like on the syllabus or nothing, so I was trying to figure out what.
Oh, so the way you access it, you have to access it through Blackboard, right? So you have to go into Blackboard, open up the main folder for our course, and then item number 3 is going to say like all assignments. You click there, and that's how you get into the course, right? So you access it through There's not a course ID. You go through Blackboard. I linked it in the Blackboard, and then once you get, like, you register and you log in, you have to actually, I think you just got the book, so you should have an access code that came with the book. And then, you know, so on the page where you're prompted for payment, that's where you submit that access code, right? So there are 2 main things, right? In the past, you might be looking for a course ID. There's no course ID. You have to go through Blackboard to access. Once you get into it through Blackboard, Then you're going to be prompted for an access code that you have to purchase. I think that came with your book. It should have come with your book. You use that access code there. So those are the two parts. I can walk you through it. Well, no, I can't because I got another class like immediately after you guys. What time is that class let out? That class gets out.
I think.
Yeah, if you got it, then I'll let it go. Okay, so let's see what we can do here, right? So in the last one, we really were looking at like a few applications of the power rule. So they looked a little different, but a lot of it was really just the power came down and we subtracted one from the power, and then we just did algebra from there to like simplify it, right? So here are like the next set of like, I guess, rules that we have for differentiation. And they're pretty similar to like what we did in the previous section. So some objectives here are to differentiate using the product and quotient rules, and then use the quotient rule to differentiate the average cost, revenue, and profit functions. Okay, so if a function is the product of two other functions, then the derivative, so the derivative of the product, okay, so the product rule goes first times the derivative second. Yes.
Excuse me, there's two people talking.
Okay, let's keep going. So the product rule goes, whenever you take the derivative of a product, it's going to be the first times the derivative of the second plus the second times the derivative of the first. All right, let me say that one more time. Whenever you take the derivative of a product, it's going to be the first function times the derivative of the second plus the second function times the derivative of the first. Okay? All right, let's see if we can see this in action. So they asked us to find this product. So the derivative is going to be the first times the derivative of the second plus the second times the derivative of the first. Okay? All right. So the first function is what just is itself, x to the power of 4, 2x cubed minus 7. So that's the first times, I'll write it like this, the derivative of the second. So we're going to take the derivative of 3x squared minus 5x. We're going to do that in just a moment. Plus the second function, which is this, times the derivative of the first, d by dx of this. Okay. All right. So let's do some simplification. The first part just persist. I'm just rewriting that. That derivative, the 2 comes down, that becomes a 6. I'll highlight it like this. Right. That's pretty much what we were doing in the previous section. Then it's an x, and same thing here, it's just minus 5. First part persist. So again, if you're trying to follow this, you may or may not be able to follow it. To me, the way that this really sinks in is not until you do it yourself. Again, and all I'm doing is saying the first times the derivative of the second plus the second times the derivative of the first, right? So then the derivative of the first is going to be 4x cubed minus 6x squared minus 0. Okay. Let me see. Do we have any factors? Can we factor anything? No. I mean, we can expand it out and then combine like terms. They actually might accept this. Let me see. I'm going to look at theirs, and they did. Praise the Lord. Right? Because I started to expand it all the way out, and I was like, no, I don't think we have to do that here. Right? So this is what we got. We just said the first times the second plus the second times the derivative of the first, and then that was our result. Okay. Let me see. Leave that as an exercise. So we saw the product rule. So then the quotient rule is done in a similar fashion. Right? The quotient rule goes. The way I remember the quotient rule is low D high minus high D low over low low. Right? In other words, the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So again, it's low D high minus high D low over low low. All right, that's just another way to remember it. I'll write it here. So you can remember this Q prime low D high, right? Minus high D low over low low, right? And that's basically this. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay. All right. So here we're asked to differentiate. So then the f prime low, which is this guy, D high. So the derivative of the top is going to be 2x minus 3. So that's low D high minus high D low, like it's just a 1 over low low, which is going to be this. I don't see any like terms or any cancellations. We can factor out an x. That'll leave us with x minus 3. I don't see anything canceling. So I think we can probably leave this one like that. Now, you know, in subsequent examples, we'll take it further, but for now, I think this should suffice. Okay, so they did expand it. We can go ahead and expand it. That's fine. So the first one becomes, if we FOIL, 2x squared minus 3x minus 2x plus 3 minus x squared plus 3x, right? And again, what I did here I did FOIL, and here I distributed. Okay. And then the bottom, I'm just going to leave it as this. Okay. Then if we combine like terms, it looks like it's just an x squared. That's a negative 5, or I guess these guys cancel. All right, that cancels that. So it looks like it leaves us with a negative 2x plus 3. Then this guy. So all we did was expand the items on top, combine like terms, and we just left the bottom as is. Yeah. We got a solid 10 minutes, so I'm gonna go with it. I'm gonna leave this as an exercise. Let's see. So if C of x is the cost of producing x items, then the average cost of producing x items is gonna be C of x over x, right? Okay, that's fine. R of x is the revenue from the sale of x items, then the average revenue is going to be R of x over x. P of x is the profit from the sale of x items. So the average profit from selling x items is going to be P of x over x, all right? So whenever we're doing average, we divide by x. Paulson's greenhouse finds that the cost in dollars of growing x hundred geraniums is given by this guy. If the revenue from the sale of x hundred geraniums is given by this, find each of the following: the average cost, the average revenue, and the average profit when x hundred geraniums are grown and sold. The rate at which the average profit is changing when 300 geraniums are being grown. So the rate means we're looking at the derivative. Okay, I know. Do I have time? Is the question. Okay, average cost. Well, we're basically dividing each of these by x, right? So the average cost, we would say that function divided by x. Average revenue, that function divided by x. And the average profit, we could say revenue minus cost, that answer divided by x, right? So I'm just gonna kind of leave it like that. Let's see the rate at which the average profit is changing. So with that, I think we would have to look at the derivative. So we have our functions for, okay, so they really only want the average profit, right? So we can take our average profit function, find the derivative. I think I'm gonna go ahead and do it. So how can I do the shorthand here? Average, let me just, like this, I guess. Average profit. So revenue minus cost. What is that, a negative 80? And those don't combine. So negative 80 plus 90 times the square root of x plus 100 times the fourth root of x divided by x. Okay, so that should be our average profit. So to do this derivative, we would have to use, we can either use the quotient rule or rewrite this, right? We can rewrite it as what? Negative 80 times x to the minus 1. A half minus 1 is a x to the negative 1/2, and that's a quarter minus 1. That, now, I feel like it would be easier to rewrite this where we distribute that x, and I think that's what I'm going to do. And I think that'll get us to the end. Let me copy this. Let me add a page. Yeah, I'll come back to that. This is slide 17. Copy. What's the time? I'm trying to get you guys out of here. And it's like the hardest ones always come like when I'm trying to like rush and get you guys out. But yeah, I think we got it. I think we can do it. All right. So let me hit paste. Not there anymore. Okay. Copy. Paste. Okay. So this was our average profit function. All I did was revenue minus the cost, and then I divided by x, right? So if this is the average profit function, I'm going to rewrite this where I'm going to distribute a 1 over x. So I'm going to rewrite this. This is the same as negative 80 x to the minus 1 plus, now that's x to the 1/2 minus 1. So now we're going to have 90 x to the minus 1/2, and then plus 100. A quarter minus 1 is a negative 3/4. So then here, I feel like taking the derivative of this is much easier than trying to apply the quotient rule, right? Because the quotient rule, we're going to have to do low D high minus high D low over low low, right? I feel like this is easier to take the derivative of. So the rate of change, so then the average, I'm going to say P prime of x. So then the power comes down, that becomes a positive 80, x to the minus 2. The negative 1/2 comes down, that becomes a negative 45, x to the minus 3/2. 3/4 comes down, that's a negative, is that 75? X to the negative 7/4. Right? Okay, let me go back and answer the question. The rate at which the average profit is changing when 300 geraniums are being grown. So then we would plug in x equal to 300. I think I'm going to just use my calculator for that. And call it a day. Okay. I think it can do derivative. Trying to think. Do I want to do that? Let me just use the function that I just found. So I'm going to go with it. 80 x to the power of a negative 2. Okay. Minus 45 x to the power of a negative 3/2. Okay. Minus 75 x to the power of a negative 7/4. Now, I'm pretty sure this calculator can find the derivative for me. I'm just going with my answer just for the sake of time. Okay. So then I want to call on that function. I think I got it actually here. Okay. And I want to evaluate this function when x is 300. Okay. So it's probably a radical. The rate at which it's changing is like a negative 0.01. So it sounds like it's going down. The average profit is decreasing. Let's see, average profit, right? So they did A for the average. Okay, and I think this is what we got for the average profit. That looks good. So then it looks like they did the quotient rule, low D high minus high D low over low low. Let me see. Right here, 3. Oh, okay. So because it's already expressed in hundreds of geraniums, we didn't need to put 300. We just needed to put 3. And negative 10. Let me think. How can we account for that? Because I think we got the 45. We got the 1/2, but that was a negative 1/2. Let me think. Give me just a moment. Yeah, I think we're okay. 11 point. I'm trying to think. Why do we have a different answer? Because we have. I think we have this guy here, right? We have this. Let me show you. Copy. So if we look at ours, I could have typed it in wrong. Let me go check there. Paste. All right. 80 x to the minus 2. That's fine. Right. That one. Negative 45 x to the, yep, I think that's okay. Because a half minus 2 is a negative 3/2. That's good. A quarter minus 2, negative 7/4. Oh, plus. That might be why it's off. Let me see. Did I miss something there? I think I did miss something. Revenue, right here. Right here. I think I found it. Revenue minus the cost. I forgot to distribute my negative. I did the 120 minus 200 to get to negative 80, but I forgot my negative. That's why it's off right here. This guy should have been, man, that one little sign just threw it threw it off enough, right? That was supposed to be a minus 100, right? That's why it was a little off. So then that makes this guy, let's see. I think that was what? Minus. Okay, so it looks like this. Yeah. This should have been a negative 100 there. And then we took the derivative. That would have made this a positive. Right? So then here, right here, change the minus to a plus, and then recall, and we get the thing. Not bad, right? It was, we still made a mistake, but it wasn't catastrophic, right? But we found it, right? I forgot to showcase that, hey, we distributed a negative, and that's how, I definitely forgot to write it for the second part. But that's how it goes, right? So, and I think we saw this one done two different ways. I rewrote mine so that it wasn't a quotient because I could, right? We were dividing by a monomial. So I distributed that 1 over x. And to me, that was easier to work with than trying to do like the quotient rule, low D high minus high D low over low low. The book, I think they did do the quotient rule, right? Right here. So you just got to take your time, write big, give yourself plenty of space, and just go piece by piece. You have to like slow down, right? And that's one of the biggest challenges with people, especially in this day and age, because of the internet culture. We're part of the microwave generation. We stand in front of the microwave like, yo, what's taking so long? It's a freaking microwave. Like, it doesn't get much faster than that, right? So we don't have patience. A lot of people don't know how to slow down. Or I know I'm talking fast because I'm just trying to get you guys out of here. But, you got to slow down and just go piece by piece, like break it into small pieces. And kind of take your time. So in taking your time, you have to give yourself time. So it takes about 4 hours every day, at least 5 days out of the week, something like that, right? And you could take other days for like rest or whatever, right? And so fortunately, I was able to catch my mistake and we got to the same thing, okay? I feel like there should be questions. I am going to pause for the cause. I know you guys are exhausted. We got a section summary there. Where's my page? I know I used it. Why y'all doing this to me? So I'm not sure. It's so strange. It's there, but it won't show. Anywho, okay. Any questions? I feel like there should be questions, but again, I also acknowledge that you guys might be exhausted. I'm gonna send a. Let me make sure it's the right folder. Yeah, that's right. Okay. So I'm sending a copy of these notes to Box, and if there are any burning questions, we're going to go ahead and end the session here. Wait a minute. Quick share options. Share. It might be 2 of them in there now. Why is it doing this? It's totally changing. spring. No, spring of 24. Traditional calculus. Notes. Handwritten notes. Whatever. Oh my goodness. It's doing attention. It's really like not going the right folder. Calculus, notes, handwritten notes. Yeah. Yeah, that's right. Choose this folder, upload. Okay. Yeah, I don't know why they did that. Yeah, they're always doing updates, and that was a little bit tricky. Okay, so if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your evening. Just take a deep breath. Shake it off. Do what you can. Get some rest, and then tackle this like when you're fresh. And again, I do encourage collaboration. All right, guys. And I'll try to go through and remember to update those late penalties. Right. All right, guys. Take care. Enjoy your evening. I'll see you Wednesday, same time, same place. Take care. Peace.
Professor C,
Yes.
you told one of us to remind you about the taking 10% off, changing it to 5%.
Yeah, I'll do that. I can't do it right this second. Just that helps that you remind me, so that way.
Nah, yeah, you just told us to remind you. No rush. I was just reminding you.
You good? Okay.
Okay.
I'll see you next time.
Have a great day.
All right, let's get into this other class. Let me see, chat. Yeah.